All right, let's run through an example of performing that algorithm that we just developed in the last video. So what we're going to do is we're going to find the binary expansion of 101, which we're interpreting as base 10. Okay, so 101 in base 10. Want the binary expansion? Well, the first thing we want to do is do 101 divided by 2, right? And then what we're going to do is perform the division algorithm. 101 is going to be 2 times 50 plus 1, right? So 2 times 50 plus 1. 101 is going to have a quotient of 2 and a remainder of 1. So we can say, well, let's set A0 equal to 101 mod 2, which is equal to 1, right? So there's our A0 value. We've got that. Now we're going to take the quotient from that division. We're going to take the quotient, which is 50, and move that on to the next step. So 50, now we're going to divide that by 2. 50 is equal to 2 times 25 plus 0, right? The remainder was 0. So A1 is going to be 50 mod 2, which is 0. Now we take the quotient from that, which was 25, and move that on to the next step. 25, divide by 2. All right, 25 is 24 plus 1, and 24 is 2 times 12 plus 1. Okay, so that means the remainder is 1, first of all, so A2 is going to be 25 mod 2, which equals 1. And then we take our quotient of 12 and carry that on. 12 divided by 2. 12 is 6 times 2 plus 0. I should have written that the other way around, sorry, for consistency. 2 times 6 plus 0. So A3 is going to be 12 mod 2, which is 0. And we take the 6, which is our div, right, and carry that on. 6 divided by 2. Well, that's 2 times 3 plus 0. So A4 is going to be 6 mod 2, which is 0. And we carry on the 3. Almost done. Let's see, 3 divided by 2. That's going to be, well, 3 is like 2 plus 1. So that's 2 times 1 plus 1 more, right? So our A5 is going to be 3 mod 2, which is 1, as we discovered. And then we take the remainder of 1 and carry that over. 1 divided by 2 is, well, 2 doesn't go into 1 any number of times, so it's 2 times 0, and then plus the 1 to get 1, right? So A6 is 1 mod 2, which is 1. And then now that we have a remainder of 0, we stop the algorithm. Great. Whew, that's kind of a long algorithm on that number, but that's what we've got. So now looking back through these, we're going to take these numbers, right? A0 through A6. Now we write them, you write them with this is the 1's place, and this is the 2's place, and this is the 4's place, and the 8's, and the 16's, and the 32's, and the 64's, right? Those are the places. So we write them from the 64th place on the left all the way down to the 1's place on the right, just like we do with, just like the base 10 system where 1's is on the far right. So it's going to be, bottom up, 1, 1, 0, 0, 1, 0, 1. And that is the answer. 101 in base 10 is 1, 1, 0, 0, 1, 0, 1 in base 2.